This is a lesson for Geometry 3.7, perpendicular lines in the coordinate plane. We're going to go back and do 3.6 tomorrow and review parallel lines. But this is the lesson for Monday, October, I think today is the 10th? October 10th. So we had some warm-up problems that we did. First thing was multiplying 3/4 times negative 4/3. And of course, to multiply fractions, we multiply straight across. So that gives me negative 12 divided by 4 times 3 is a positive 12. So that gives me negative 1. So that's what you should have got for that one. Number 2, what does the m stand for in y equals mx plus b? Of course, the m right there stands for the slope of a line, and the b stands for the y-intercept of a line. Number 3, write the equation of a line that has a slope of 4 and a y-intercept of 10. Well, if I started out with mx plus b, I would then replace m with 4, so y would be 4x and then plus 10. So that was the warm-up answer for that one. And then number 4, find the slope of the line that passes through, this is x1 and y1, x2 and y2 if I number those. And remember the slope formula is y2 minus y1 over x2 minus x1. So that's going to be 0 minus 6, all divided by x2 is negative 9 minus 5. Now 0 minus 6 is a negative 6. Negative 9 minus 5 is a negative 14, so that reduces to a positive 3 over 7. So a positive answer because the negative divided by negative is a positive. Okay, those were the warm-ups that we did. Then, getting into slopes of perpendicular lines, okay? The first box here, the first idea says if two lines are perpendicular, this is the symbol for perpendicular, then their slopes have to multiply to negative 1. So here's an example for you, okay? So I have two equations, y equals 2/3 x plus 1. I put that onto the graph, and then y equals negative 2/3 x minus 4. 2/3 x plus 1 has to be this red graph because the slope is up 2 and over 3. And then the blue graph has to be negative 2/3 x minus 4 because you go down 3 and over 2 to get the slope. So now, we can see that these two lines are perpendicular to each other by multiplying their slopes. So the slope of this line is 2/3. And the slope of this line is a negative 3/2. So if I multiply that together, I get 2 times negative 3 is a negative 6. 3 times a positive is a positive 6, which of course is negative 1. So since their slopes multiply to negative 1, according to this, the two lines must be perpendicular. And then from the graph, it sure looks like they are perpendicular. It looks like they are definitely meeting at right angles. Okay, now box number 2 says, are these lines perpendicular? How can you tell? Well, again, let's look at their slope, right? This is the slope of 1/3. This has a slope of negative 1/2. So I'm going to do some math here. If I multiply the two together, 1/3 times negative 1/2, I get negative 1/6, and that's definitely not the same thing as negative 1, so the answer is no. They are not perpendicular. They're not perpendicular. Okay, so that's box 1 and 2. So let's talk about the general form now. So are these lines perpendicular? How can you tell? Well, these don't look like they're in the form of y equals mx plus b. These are different, right? So what we need to do is we need to change these into y equals mx plus b form. Here's how you do it. So if I had 4x plus 5y is equal to 2, I want to solve for y. So 5y is going to equal negative 4x plus 2 just by moving to the other side. And then, of course, dividing by 5, or a little algebra review. So y would be negative 4/5 x plus 2/5. Okay. Now for this one, I'll start again. I'll go 5x plus 4y equals 3. So I want to get the y by itself. I want to solve for y, so I'll subtract 5x from both sides. So 4y is equal to negative 5x plus 3, and then divide by 4. Divide by 4 and divide by 4. So that means that y is equal to negative 5/4 x plus 3/4. And then the question says, are these lines perpendicular? How can you tell? So I have to look at their slopes. So the slope of this line is negative 4/5. The slope of this line is negative 5/4. if I take those two slopes and I multiply them together, negative 4/5, and I multiply by a negative 5/4, well, I get negative 20 all over 5 times 4 is positive 20. Negative 4 times a negative 4 is a positive 20 divided by a positive 20, which is a positive 1, which is not equal to negative 1, which is what this thing said, right? If they are perpendicular, then their slopes multiply to negative 1. Well, since these slopes multiply to a positive 1, the lines are not perpendicular, and that's how you can tell. Okay, great. So let's practice writing some equations. So here's the equation of a line. This is the fourth box. Y equals negative 2x plus 5. Okay, I'll get a little thicker here. Can you find the slope of a line that would be perpendicular to this line? Well, if it's perpendicular to this line, you may recall that slopes have a opposite reciprocal. So the slope that would be perpendicular would be a positive 1/2 x. Because this slope is negative 2, the reciprocal of negative 2 is a positive 1/2. So that is a slope that would be perpendicular, because when I multiply negative 2 times 1/2, I would get negative 1. So I'm dealing with a positive 1/2 now. Then it says, can you find the equation of a line that's perpendicular to my line and make it go through the point 4, 0? So I'm going to start off with this. Y equals 1/2 x plus b, right? And all I need to do now is solve, plug in my x and plug in my y, and solve for b. So if y is 0, so 0 equals 1/2 times x, which is 4, plus b. So that means that 0 is equal to, well, 4 divided by 2 plus b, so b must be negative 2. So my answer is this, right? I want the equation y equals 1/2 x minus 2. So if I were to graph that one, right? So if I were to graph y equals 1/2 x minus 2, and take a look at the graph, so I'd have this, right? And then let's graph the original equation, which was negative 2x plus 5. Let's graph that one too. And hopefully these will be perpendicular. Y equals negative 2x plus 5. Let's put that one on there. That's an S. Plus 5. Okay, yeah, this is looking like they are very perpendicular, right? And the other criteria was what? That the point had to go through 4, 0. So if I move my graph over, if I move the graph over, does it go through 4, 0? It sure does. So the answer is 1/2 x minus 2. That's the one that we're looking for. And it goes through the point 4, 0. Look and see right there. So you'll definitely know how to do one of those. That'll be on the quiz. Okay, and then finally, how do you graph a line on graph paper, okay? So the fifth box says graph the two equations below on graph paper with your ruler, okay? So let me show you how to do this. Okay. So here's some graph paper, okay? We're going to graph the line y equals 3x minus 2. You start at the minus 2, so go down 2 spots. Oh wait, let me zoom this in for you. Okay. There we go. Okay, so we'll start at the minus 2, down 2 spots. I'll put a dot there, okay? From there, we take the slope, which is up 3 and over 1. So we're going to go up 3, 1, 2, 3, and over 1. Put another dot there. And then we have enough information to graph that line. Okay? Now, for 3y plus x equals 15, we have to do some work. Okay? First thing that we have to do is we need to get this into y equals form. So I'll come over here, show you that. So we'll do this. 3y equals negative x plus 15. So dividing by 3 everywhere, I get this. Y is equal to negative 1/3 x plus 5. So to graph that line onto my equation, I'm going to start by the y-intercept going up at 5. So let's go up to 5. So let's bring this down. Okay. Let's go up to 5. And then from 5, we're going to go down 1 and to the right 3. So down 1 and to the right 3. 1, 2, and 3. Put a dot there. And we're going to connect those lines, although I didn't do a very good job. That's why I use a ruler. Okay, so to really get these lines on the graph here is the actual graph. There's the first one. That looks pretty good. And there's the second one. That looks pretty good too. That line is much better than mine. So I'll clear this. There we go. So now I have these two graphs over here. And the question down below says this: are they perpendicular? How can you tell? Well, here's what we can do again, right? We can take the slope of this line, which is negative 1/3. So I'll use green, right? We'll take negative 1/3, and we'll multiply that by the slope of the other line, which happens to be 3. So negative 1 times 3 is negative 3. 3 times 1 is 3. So I get an answer of negative 1. And since I did get a negative 1, remember, that's the definition. Two lines are perpendicular if their slopes multiply to negative 1. So since I did, I can say, yes, my lines are perpendicular. And there you go.